Hello, everyone. I hope you all had a good weekend, and I hope the exam went well for most of you, or all of you, I should say. And today we're going to start a new topic, and this is going to be Chapter 10. So I'm going to share my screen so I can get to the notes so we can look at these together. Chapter 10 is similar to, this is not where I wanted to be, sorry. Chapter 10 is similar to, there we go, this is where I want to be, Chapter 9. Now, Chapter 9, we did confidence intervals. We did confidence intervals for means, which is numerical data, confidence intervals for proportions, that categorical data. Confidence intervals is similar to Chapter 10 in respect to that it's called inferential statistics, which means that we're taking a sample and we're going to take the information we've learned from the sample and project that against the whole population. That's called inferential statistics. It's like very realistic. This is what happens all the time, right? Someone's not going to maybe do a study of an entire population, but they're going to study a sample of that population and generalize that against, that information against the population. So what we're going to do today in Chapter 10 is called a hypothesis test. In hypothesis testing, we're going to use this 5-step process. The 5-step process, it's pretty lengthy, and the first time you go through a full hypothesis test, it will take you a really long time. Like, it could take 30 minutes, even more for some people, which is okay. We get used to it. We get used to the write-up, we get used to how to explain things, and then we get really good at it, and it goes really quickly for us. If you're moving on to Stat 2, this is what we do every single day in Stat 2. We do hypothesis testing. So this is very important for the entire class in general, but if you're moving on to Stat 2, it's really important. So what I want to talk about first is for the hypothesis test, we're going to determine if our sample data has evidence to support this new idea, okay? So a hypothesis is an idea or a theory, and a hypothesis test is to see if we have evidence to support this new idea. So when we write up a hypothesis test, we have our null hypothesis, which is H naught, and that is our common view. That is also the center of our curve, and it's assumed true until we have evidence to prove that it's not. When we're looking at the null hypothesis, I want you to make a note that the null hypothesis you can always write as equals. So you can always write that P equals some value, or mu always equals some value, okay? Or you can write it opposite from the next hypothesis, which is the alternative hypothesis. But I want you to notice it's equals, or it could be greater than equal or less than or equal, okay? So it always has the equals, but you can always just go with this first option where it's just plain equals and skip the inequality. I just want you to know that. Most of the time in Stat 1, we just write it opposite from the HA, which is the alternative hypothesis, which is the second one, because it's just simple that way, and that's fine. All right, so that gives me to this next one, the HA. This is the alternative hypothesis. This is the new idea. This is the statement that we're trying to find support for. So this is the whole thing behind the idea behind the hypothesis test, is that we're trying to support this. My HA is going to always be like a not equals, or just an inequality that does not have equals. So not equals, less than, or greater than, okay? And like I said, you can always write your null opposite from the HA. So if your HA is less than, then your null would be greater than or equal to, okay? So that's about the ideas. My 5-step process, okay? So in Chapter 10, we're going to learn a 5-step process. I use this 5-step process all through the rest of this course, and I use it all through Stat 2. The 5-step process is supposed to help you walk through. It's supposed to help guide you, like to talk about and understand like what we're studying and what we're trying to do. Okay, so it's going to seem, like I said, really long, but it's really there to help guide you. It's really good process. It just seems overwhelming. So I'm not going to show you all 10 steps today. We're going to take the next few lessons to learn the five, I think I said 10 steps, 5 steps, okay? We're just going to talk about the first 2 steps. Now, these are going to start looking familiar because I actually had these in on the activities, the team activities for the confidence intervals. So some of this will look familiar, which is a good thing. So the first step in our 5-step process is called the population step. This is where we're describing the population. I want you to understand we're not describing the sample here, we're describing the population. So when we're looking at a 5-step process and we're talking about the population step, we're looking at the objects, variable, the unknown, and my goal. So these are the 4 parts under my population step. The objects are who we are studying. Now keep in mind, it's not always people, right? It's an object that we're studying. It could be computers, it could be an animal, it could be all different things. I want you to understand when I say individuals, I'm not saying people, because an individual, like one computer might be an individual that we're studying. So the objects are all individuals in the population. So say we're, in the example today, we're going to look at RIT students, and I'm going to sample some of the RIT students. My population, it's all RIT students, okay? The variable is what we're studying. So remember what a variable is? It's what's changing from individual to individual, and that helps us decide what it is. My variable drives my unknown here. So my unknown, so if my variable is numerical, then my unknown is my population mean, mu. If my variable is categorical, so it's more like a yes-no question, then my unknown would be P, the population proportion. So it's what we're trying to solve for in the end, okay? And then when you're looking at your unknown, you're going to define it, and I will show you when we look at the example, because I think that will be helpful. Then my goal is always to find evidence to support my HA, which is my alternative hypothesis. In the beginning, I tell all of my Stat 1 students that we should hold off on the goal until we do the second step. Because in the second step, we define what HA is, and then we can come back up and write the goal. And then when you get to Stat 2, you get really good at it, and you kind of already have an idea of how you're going to define your HA before you start your process, so then you can write your goal right away. But that's what I always kind of tell people, okay? So that's my first step. I also want you to note that we have 5 steps, but within each step you have 4 parts. So it kind of helps you keep on track. It helps you recognize if you're forgetting something, okay? The next step is called the method step. This is where we're going to define or explain the process that we're going to use. So in this method step here, we are going to have 4 things again. We're going to define the null, H naught, alternative, or hypothesis, sorry. My alternative hypothesis we're going to define. We're going to identify what alpha is. We're going to talk about that in a second. And we need to identify what curve we're studying. So my null hypothesis, I already told you up above a little bit about the null hypothesis. And up here in this bubble, I have that we have 3 ways we could set up the null and the alternative. I like to say, well, let's write out our alternative, and we get this right from the problem. Remember, the alternative is the new idea. It's what someone's trying to prove. And then the null is written after the alternative, and it's just opposite of it, okay? So we're going to keep those in mind, and we'll see exactly how to do this when we look at an example. Alpha, okay? We've already talked about alpha before, because alpha is the area in my tails, right? The same thing as confidence intervals. It's just in confidence intervals, we had 2 tails. Now, here we don't have necessarily 2 tails. I'm not going to get into it a lot right now. I will show you some visuals, all right, so some graphs with alpha, but I want you to keep in mind alpha is the area in my tails. We're given alpha. It's called the level of significance. And if you're not given alpha, because every once in a while we're not given alpha, I try to give it to you most of the time for stat 1. But if you're not given alpha, you're going to assume that it's 0.05 for any regular scenario, and then you're going to assume it's 0.01 for a medical life or death situation. If I don't give it to you, and I give you some sort of a medical situation and you're not sure if you should choose 0.05 or 0.01 because you don't know if it's life or death, then it doesn't matter to me. Then I would just grade your work based on what you told me. So I want you to understand, if I'm really going to be particular about it, I'm going to give it to you. It's not like a guessing game. It's not about that. So like on an exam, I always give it to you guys. But like for team assignment, I might not give it to you and let you decide. The curve we're on, this is going to go same idea with confidence intervals. We're using a T curve. Remember we had that T value for my numerical data. That's if we have means, standard deviations, and my unknown is mu. Or we'll be on the Z curve for my categorical data. This is proportions. We have P and P hat, right? So we just want to identify what curve we're on when we're doing a hypothesis test because it matters, okay? It matters in some calculations that we're going to look at. Let's take a look at this example. So it's commonly thought that a small percentage of college students approve of a university's administration. An RIT professor wants to convince the campus community that more than 67% of the RIT students approve of the university's admin. I want you to set up the population and method steps to start the hypothesis test using a 5% level of significance. So right below, I have the completed example. I highlighted some information. So the first things I highlighted were more than 67%, because we're going to use that for our HA, and the 5% level of significance. This is my alpha. So let's walk through this. So my population step, I first want to define my objects. My objects are who I'm studying. This is all RIT students. It's not just the few that are in the sample, it's all of them, okay? The variable, do the students approve of the university's admin? It's a yes, no. When you see something like this, when it's worded like a question with a yes, no, you should recognize that that's proportions, that's categorical data, right? Someone either answered yes or they answered no. So they're either fit in the category of yes if they approve or they don't. Then that leads me to my unknown, which is P, because it's categorical. It's my population proportion. I want you to define P at this point. So I'm very picky about this, and I really like you to write it out nicely. So what you're going to do here for your unknown, you're going to take what you picked for your objects. It's not like you're choosing, it's out of the problem, right? And what your variable is, and you're going to put them together in the statement for my unknown to define P. P is the population proportion, right? So it's the proportion of all RIT students who approve of the university's administration. So I'm taking the top two, the objects and the variable, and putting them together here. That's something that's just going to take a little time for us to write and get used to. My goal, I'm going to leave blank. I know it's right there. I don't want you to read it. We're going to come back to that in just a minute. Let's jump to the method step, okay? So my method step here, I have my null I need to define, my HA, my alpha, and my curve. I'm going to start with the HA first because that's what I have. So if you go back up to the problem, it says that a professor wants to convince the community that it's more than 67% approved. So more than 67%. So that's saying that my new idea, this alternative hypothesis, is that P, the population proportion, is greater than 67% or 0.67. So I'm going to fill that in here under my HA. P is greater than 0.67. Now my null, I'm going to either write it as exactly opposite or I'm going to leave the equals. Or put the equals in there. So my null, I have P is equal to 0.67, or I'm going to put in parentheses here, or we can write it as P is less than or equal to that 0.67. So there's two ways I can write that one. Either one works. It does not matter to me, okay? So I'm going to just adjust this. Oops, so it looks nice for you guys. Oh my goodness. Oh, having issues. Okay, there it is. So that's my HA and my null. I'm going to finish my method step, then we'll go back up to the goal. Alpha is my level of significance. This is 5%. It was given to us in this problem. I'm on the Z curve. The reason why I'm using the Z curve is because we're studying categorical data, P proportions. Okay, so it's cut and dry like that. It's what you have, that's what's going to drive you for what curve you're using. Let's go back up to the goal, then we're going to look at the picture below. My goal, it's always to show support for my HA. So I'm going to take, I could say that, to show support for HA, but I don't want you to write that for me. I want you to write it out. Everything needs to be written out for me. I like to see it all nice. I want to be able to read these steps and know what the problem's about without reading the problem, okay? My goal is to show support to say that more than 67%, so I'm reading it right from here, or more than 0.67, 67% just reads nicer, of all RIT students approve of the university's admin. So what happens is I'm taking P and I'm replacing with how I defined it. It's with words. So to show support that P is greater than 0.67, so to show support that the population proportion of RIT students who approve of the university's admin is greater than 0.67, I'm just plugging it right in, right? So I'm not even making up a new statement here. I'm just taking the symbols and replacing it with the words that I already defined in my population step. So I get kind of excited about it because I just do this all the time in Stat 2. So I just want you to realize it's not as hard and it's not as time consuming as it seems in the beginning. It's new to us. So it just seems a little bit difficult. I'm going to show you a little visual just at the end here. So here's my Z curve. I want you to realize my Z curve is centered at my null hypothesis. This is right here, my common view. So it's at 0.67, okay? That's my null, that's my center of my curve. My alpha, 5%, is up here. It's my area and my tail up here, okay? We don't know what this stands for quite yet, okay? It's just telling me, well, my area to the right, we don't know what that value is just yet. And we won't really know what that value is, but we're going to find out another value, which we'll get to in another lecture. But I just wanted to let you know. So right here is my 5% in my tail on the right side. The reason why it's on the right side is up here, my inequality symbol in my HA is a greater than. I'm going to show you more of those, and I don't know if it's next lesson or the lecture after that. But so that's just a little visual to give you an idea of what we're looking at, and we'll be calculating some probabilities and stuff. So sometimes it's nice to have a little visual. So anyways, I hope that helped. You will notice that you don't have any homework due right now because the way the book handles this material is different from how I handle material. So the book will throw at you all of the steps to the process, and they don't even really do a full 5-step process how I do it. And they just throw a full hypothesis test at you for like proportions in 10.1 and then means in 10.2 or something like that. So what I need to do is I need to go through all these lectures to show you all the 5 steps first before I can assign the homework for you to work on the homework. Otherwise, you won't know how to finish the homework. So it doesn't make sense. So you will see that there's no homework assigned or due yet. I don't even know if it'll be out there next week. It might even be like that last week. But just so you know. But you will be practicing this in your team assignments that you have, and we're going to add another step that we will add to the team assignments as well this week. And what I'll do is I will keep continuing with this problem from our example in class, each class going forward for every step. So we're going to just keep adding on that step, and then I'll continue with some other examples too, just so we can see some completed examples at the end of all of this. Okay? All right. Well, I will see you guys in the lecture chat if anyone wants to ask questions on Monday or on Wednesday at 12:30. All right. Thanks a lot.